Now this question's a little bit trickier, right? Because I've got my inclined plane here, and it's at 40 degrees. But the box is down here, and it's moving, has an initial velocity upwards of 5 meters per second. All right, so that's upward is positive, so V1 is positive 5 meters per second. Now the acceleration, now we've said the acceleration is essentially g sine theta, but now that we're dealing with sort of an up and down, I think we're going to want to put that negative. So your A will be negative, and so that's important that you make that negative. The question is, how far will it go up to the top? So when he's sliding up to the top, he's eventually, gravity's going to kill him and he's going to stop. So you know that V2 is equal to 0. So now you can use equation 3. V2 squared is V1 squared plus 2A delta x. Now watch it. The A will have to be negative, and you're solving for x. That's the answer for part A. For B is how much time before the box returns to its original position. So what I just did is I just used the standard equation, x2 equals x1 plus v1t plus 1/2 at squared. Now x1 and x2, we're going to start at what point? How about 0? So, and it's going to come back to where it originally was. So 0 equals 0 plus, you know what V1 is right there. You'll have found what A is here. Watch it. It's got to be a negative answer. And you're going to have a T here and a T here, slightly quadratic. There's actually a way to get the T's to cancel if you want to do the full algebra thing, and you'll solve for T.